I am Anil Kumar. Welcome to my series on probability. Now, the unit on probability is never completed without understanding probabilities in the game of cards. In this video, we are going to discuss a very interesting game which is played with three cards. It's also known as Blitz or Indian poker. Many students are not aware of this game, so I'll take some time to explain, and then we'll find probability for each and every case. We'll also take up two questions related to poker, where five cards are distributed. So, first, as you know, there are 52 cards in a deck, 13 of each kind: ace, 2, 3, 4, 5, 6, 7, 8, 9, 10, jack, queen, and king. Ace can be also placed after the king. Four suits: spades, hearts, diamonds, and clubs. 26 red cards, which are hearts and diamonds. 26 black cards, which are spades and clubs. So the sample space when we are distributing three cards each, in this case, will be to draw three cards from the 52, right? So we have to draw three cards, and so it is 52C3. So 52C3 is going to be sample space. So when we find probability, we'll always divide by this particular number, which is 22,100. Is that clear to you? So this is the number which goes in the denominator when we divide. Okay, divisor. So these are the number of hands also. Sometimes the question could be, how many hands can you have when you draw only three cards from a pack of 52? There could be 22,100 hands, right? 22,100 hands. Now we'll consider the probability of following hands in the game of three cards. So when you get three cards in your hand, we just call it a hand of three cards. And as I said, we'll extend it to poker, where five cards are distributed with two examples. So the three cases which are shown here are in the rank wise. If you get three of one kind, right? All aces, all kings, or all queens, or all twos. This is called trail, and this is considered to be of the highest rank. Next to that is a flash with a sequence, same color and in order, right? Ace, king, queen could be an order. Ace, 2, 3 is also considered an order. 2, 3, 4, 4, 5, 6, and so on, of the same color. So that is ranked as the second. Then we have a sequence which is not of the same color. So you can see that this is kind of mixed up. In the first case, we have all of hearts. Similarly, we could have all three of clubs, spades, or diamonds. Now, this is called the color. So let me share with you three more, which are considered to be pretty high in ranking. So the fourth position is of color. All of the same color, all of the same, like diamonds could be all hearts, but not in a sequence or not with a pair, right? Now we'll talk about a pair here. We have two sevens, two aces, two kings, something like this. This is fifth in the rank and it's called a pair. Then, if nothing of the above is there, then we just match with the highest card. In this case, the highest card is king. So that is of the lowest rank when you're distributed three cards, right? It's also treated as Indian poker, Teen Patti we call in Hindi, and it's a very popular game. Now let's see how to find the probability of these events. So we'll begin with the pair itself. When I say pair, that means we have two of the same kind. So let's say double double, right? So DD and A is a different card. So in that case, what is really happening is we are actually distributing three cards. And we need to get a pair means the same kind, right? So there are, as you know, 13 of the kinds, right? So first thing is, from you have to select which one. So here, as I've shown here, pair of seven, it could be pair of 1, 2, 3, 4, right? 13 of them. So 13, choose one is the kind which we are first selecting, and then from that kind, for every kind, we have four cards each, right, of different suits. So we'll choose suits. So it could be any two of those four. So that is how we fill in these two positions, right? So that belongs to 13 of any, and from that, we are going to choose 4, you can also write like this, 4 choose 2, correct? So that gives you the first two positions. Now in the third position, we should have some other card, and definitely it is not from the kind which we selected, right? And therefore, we have to select now from 12, and any one card from 12 will do. Now that particular card, when you select of the kind, let us say it's a number a is 2, a is 2, 3, 4, and in this case not 7. In that case, that could be of any suit. So there are four combinations for that. So 12c1 times 4c1 gives you the position, how many of those kinds can occupy the third position. Product of these, that is the combinatorics basic rule of multiplication, right? So these are selected in a sequence in this way, and so their product represents the total number of favorable options. And when you divide this by 15c3, 15 choose 3, you get your answer, which comes out to be 0.1694. So around 16% chances are there of getting a pair, which is not bad. Now let's look into the second option. We call it a color sequence, right? We call it a color sequence. Also, in the terminology of poker, you can call it a straight flush, correct? And the one which I have shown here is also called royal flush, correct? Ace, king, and queen kind, right? Of course, in poker, you have 5 cards. In 3 cards, you can have only 3. So for 3 cards, this becomes a royal flush. Well, we'll talk about the color sequence in general. It could be 4, 5, 6, 7, 8, 9 of any color, the suit, which could be diamonds, spades, hearts, or clubs. So that is what we are looking into. So what we have here is, there are 4 suits. So it could be of any of those 4 suits. And how do we get a sequence? Let's try to understand this. Now, if I have ace, 2, 3, then that forms a sequence, correct? Similarly, another sequence will be 2, 3, 4, right? And then we could have a sequence which is 3, 4, 5. So like this, how many sequences can we have? Well, the last one will be queen, king, and ace, right? Ace could be placed on the other side. Now, queen is 12th, right? So 1, 2, 3, 4, ace, king, queen, jack. So after 10, we have jack, queen, king, right? So jack is 11, queen is 12, and king is the 13th card in our sequence. So that means we in all have 12 sets of these, right? So these are the 12 sets. Now these 12 sets could be of any particular suit. 4 suits, right? So 12 times 4 gives us all the options divided by 52c3, which is our sample space, and that gives you an answer which is 0.00211719. Pretty low. Do you see that? Just about 0.2%. So that is the uh, significance of getting this particular card. It's a very high ranking card. Next to trail, okay? Now, let's look into the other combination. We call this as a color flush, all 3 of the same suit. Now, we'll look into the probability of getting all 3 cards of the same suit in a game of Blitz, where 3 cards are dealt to each player from a deck of 52. We'll exclude the sequences in this case, very important. We have already considered the sequences. If you get a color sequence, we'll treat it as an example to the second ranking card in our sequence, right? In a series of poker, right? So now let's talk about the color. Now, color means you could choose one of the 4 colors, right? So we have 4 suits to begin with. So those are 4 possibilities. You could also write this as 4C1, correct? So you select one of those 4. And once you do that, then you have to select all the 3 cards from that particular suit, and that gives you the combination 13 choose 3, right? So all of the 3 cards of that. Now from this, you need to exclude what? Exclude the sequence part, right? And as we understand, there are 12 of each card within the sequence. So you take away those 12, right? Now, so you take away those 12, and these 12 are of 4 different colors. So you could write in this particular fashion, correct? Another way of writing the same thing will be 4 times 13c3, and from here we can take away 4. right? And then we could take 4 common. What I'm trying to say is minus 12, and then we could take 4 common. We could write like this also, correct? Because 4 are each suits. So considering the cards themselves, you can choose all combinations of 13C3, right? But from those, take away the ones which form a sequence, correct? Which is 12 of them. And then, since these are 4 different suits, multiply by 4. So that is how we are going to do it. So either way, you could write in the numerator, the denominator is 52C3, and you can now do the calculation, which results into 0.0495927. So around 5%. So 5% chances are there to get a color. Now let's move on and take the other option, which is for us a sequence. Now this is a sequence which is not, we'll exclude the color sequence this time. Okay, right. Now can you tell me what is the probability in a 3 card game, which is also known as Blitz, that you will get a sequence, which is like shown here? Perfect. So as you can understand, there are 12 sets of sequences which you will always get. Now from these 12 sets, we have to exclude what? We have to exclude the color sequence, right? Because we're treating that as a much higher ranking card, right? This comes next to that. Perfect. So what we've done here is we know there are 12 of these. Now there are 3 positions where we can fill these cards. Now these could be amongst any 4 sequence. This could be like hearts. It could be of spades. Okay. It could be diamonds, or it could be clubs. Okay, so out of these 4, we there are 4 types. So that is, we could fill a 4 cube. But if they are falling in the same kind, that will be only one option. All hearts, for example, correct? All hearts, for example. So that will be only one out of these, right? So 4 cube minus 4 will give us that particular number, right? Each one of them. And so we get 12 times 4 cube minus 4 in our numerator, and we divide by 12, choose 3 to get the answer. So I hope this is absolutely clear, right? So as you understand, we have 12 sets of these sequences. These could be in any of the 4 colors for these 3 positions, right? So that is how you get 4 to the power of 3, correct? And one in which out of these it's all of the same color. Those will be 4 of each kind, right? One of each kind, correct? So that is minus 4, and then you multiply by 12 because there are 12 sets of these, and you get your numerator, and you can calculate the answer, correct? 0.032579, which is around 3.2%. Pretty low, but it's a very high ranking card. Now, the highest ranking card is, of course, the trail, 3 of the same kind. Good. So how do you get the probability of this? Well, you have to select one of those 13 kinds, that is the first thing, and then all the 3 from that particular kind. So that is as simple. And then divide by the total combination. 1 over 425 gives you that jackpot number, which is 0.0023594. So 0.23% are the chances of getting a trail in the game of Indian poker, a 3 card game, or Blitz. Now, here is another very interesting. Most of the time, what you land up with is a card, which is not a pair, which is not a sequence, which is not a color or a flush, not a straight, as you have seen in previous cases. So what is that? So something which is not all of that. What is the probability of that? So we're going to now see how do we exclude all those combinations and then write down the probability of the most frequently received card in the game of poker. Okay, so in this case, the question here again is, we're looking into the 3 card game, not pair, not sequence, or a flush, correct? So probability of getting a 3 card which are all different, not of the same color, and are not in a sequence. In the game of Blitz, where 3 cards are dealt to each player from a deck of 52 cards. Okay, now in this particular case, how do we go about? We know as far as the all combinations are concerned, we know that is we have choices of 52 out of 52 choose 3, that is the total combination still, because you are dealing 3 cards. Now let's look into how do we deal them. So well, we have to have 3 different numbers, kinds, 3 different kinds. We have 13 of all, so let us select 3 different kinds. Once you do that, so we know that all kinds are different. So in that case, we have avoided the pairs, correct? So no 2 cards can be of the same kind. That means a number like 7, 7, 8, 8, and so on. So 3 of different kinds, and there are 13 kinds in all. Now, out of these kinds, they could be like arranged in a sequence. So we have to avoid those 12 also, correct? So minus 12 is to avoid the sequence part of it. Now, all the above kinds could be of 4 different suits, and that is how we get these 4 cube. Now, out of this 4 cube, there will be 4, which will be of the same suit. So we have to avoid the same suit also. So avoiding all those things, multiplying with the number of cards which we are dealing with, we get the numerator, which is 13 choose 3 minus 12 times 4 cube minus 4, and then divided by the total number of ways of dealing these 3 cards from the pack of 52 is 52 choose 3, and we get an answer which is 0.7438914. So around 74% times what you get is something which we are only comparing the highest card, right? So that is a most frequently dealt card in a game of cards. Now that is the kind of all the combinations which you could get in Indian poker, which we also call Teen Patti. Now let's take up a few examples for the poker game, which is dealt with 5 cards. Here's another video where I've dealt in all the cases, about 10 of these cases of the poker game, when we'll talk about the single pair, double pair, right, and straight, flush, and all those things. But that's a different video. Now here there are 2 questions. I'd like you to, on the knowledge which you got from here, answer these questions. So question number 7 is, you randomly draw 5 cards from a deck of 52 cards. What is the probability of getting 1 spade and 4 diamonds? So what you have to get is 1 spade and 4 diamonds, correct? So what is the probability of getting that? So you can actually pause the video, answer this particular question, and then look into my suggestions. So we need 1 spade and 4 diamonds, right? Okay. So I'm just giving you time to write the answer. How do we do it? Well, 1 spade is 13 choose 1. There are 13 spades, as you know. So 13 choose 1 gives you 1 spade, and you want to choose 4 diamonds. We have 13 diamond cards, so choose 4 out of them, and total number of combinations when you're dealing with 5 cards from a pack of 52 is 52 choose 5. So divide by that, and that gives you the probability of getting 1 spade and 4 diamonds, and that is 0.00357643, correct? So that is how you can find this particular probability. Now here is another question where we are dealing with a very important case, which says, you randomly draw 5 cards from a deck of 52 cards. What is the probability of getting at least 1 card from each kind? You have to get 1 card from each kind. You know there are 4 each suit, right? You know there are 4 suits. So that means one will be of 2 cards will be of the same suits, right? That is what it is. So that's how it is. So let us say 1 of each kind. Okay. So that is 13C1, 13C1, and 13C1. Perfect. So you get 1 of each kind. Now, for one kind, for one suit, 1 of each suit, right? 1 of each suit. So it should be 1 of each suit. So you get 13 choose 1, 13 choose 1, 13 choose 1. But for one particular suit, you'll have to select 2. Let's say diamonds, you select 2, right? So 13C2, correct? Well, if you select 2 from the diamonds, you could have selected 2 from hearts, spades, or clubs also. That is why we'll multiply by 4, because we have 4 choices for that particular suit. And that is how we get a numerator. Divided by the denominator, which is 52, choose 5, we get our answer, and that is a card which is not a very high ranking card, and it has about 26% probability. So I hope you understand this. So that actually brings us to the end of this particular session of learning how to find probability when dealing with cards. I hope that gives you a good idea. Feel free to write your comments, share your views, and if you really like my videos and subscribe to them, that'd be great. You can also learn from me. You can send me an email on the given address here, and then we can have some Zoom sessions and then learn. I can share some knowledge with you. Thanks for your time and all the best.